This data sufficiency question is one of the QuickStart questions on MBA.com, so you have free access to this. And you can see here we are asked about factors. In this case, whether or not k has a factor in between 1 and k itself. And you wonder about that. Well, what's going on here? And your initial thought might be, well, sure it does. So let's take an example here. Suppose k were 8. And I said, all right, 8, we'll do a little factor tree. So 8 is 1 times 8. 8 is 2 times 4. And this says factors greater than 1, so we can rule out 1 and less than 8, so less than 8. But yeah, we have a factor of 2 in here. We have a factor of 4 in here. But then you ask the question again. The question is, does k have a factor between 1 and k? So what's the question? The real question here, is whether k is a prime number or not. Suppose k were 11. No factor between 1 and 11. K is a prime number. So here's a great example of when you do a data sufficiency question, asking, well, what's the question behind the question? What do I really need to know? The question is really, is k a prime number? Is k a prime number or not? And as you know by now, prime numbers are a subject you want to think about all the time on the test. And here, particularly when you have a question that talks about factors, that uses the word factor. Okay, well, let's go to a new slide here and I'll write out the statements. Statement 1, k is greater than 4 factorial. All right, what does that mean? So k is greater than 4 factorial. We know by now 4 times 3 times 2 times 1, which is 12, 24. So k is greater than 24, which means k could be what? Well, it could be 25, could be 26. I'll write a few of these, 27, 28, 29. So is k a prime number or not? Well, 25, not a prime number, 26, 27, 28. On the other hand, 29 is a prime, and so is 31, so is 37. There are an infinite number of prime numbers. Statement 1 does not give us enough information to answer the question. We can't say that 1 gives you sufficient information, and therefore we can't say that each statement gives you sufficient information. So A and D are both out. Now, statement 2 is really interesting and more complicated. I'll do a new slide for statement 2. We have k a number greater than or equal to 13 factorial plus 2, but less than or equal to 13 factorial plus 13. And you wonder, is k a prime number or not? Which is the same as asking, can k be divided by a number other than 1 and k itself? So k, it could be 13 factorial plus 2, plus 3, plus 4, etc., all the way up to 13 factorial plus 13. Do we know for sure whether or not k is a prime number? Well, let's start on the left and move to the right. So 13 factorial plus 2, is that divisible by anything, or is it a prime number? How about we tried to divide by 2? Well, we saw something like this before. I could turn that into 2 different fractions. 2, of course, divisible by 2. 13 factorial, well, yeah, that's divisible by 2. 13 factorial is what? 13 times 12 times 11, all the way down to times 2 times 1. So that whole thing, absolutely divisible by 2. And here again, plus 2 over 2. So 13 factorial plus 2, well, that's a whole number that is divisible by 2. Maybe divisible by other things as well. It's some gargantuan number, but we know it's divisible by 2. So far, it looks like k is not a prime number. Now let's move to the right. How about 13 factorial plus 13? So 13 factorial, and I'll just start to write it out as 13 times 12 times 11 times 2 times 1. So all of that plus 13. What can that be divided by? Well, it can definitely be divided by 13. And here, if I canceled the 13, so we'd be left with what? 12. 12 factorial plus at the very end, 13 divided by 13, 1. So 13 factorial plus 13, that's not a prime number either. How about any other possible value of k? Well, so try to put this in the middle. How about 13 factorial plus 5? Well, 13 factorial plus 5, definitely divisible by 5. So what do we know? K definitely not a prime number. We go back to the original question. Does k have a factor that is between 1 and k? The answer to this question is yes, it does. So if I write on my 1, 2, 10 again, we already said 1 not sufficient, each not sufficient. But here, statement 2 does give you sufficient information to answer the question. So answer B. This would be considered one of the harder questions on the test, one of the harder questions in the QuickStart. I think a very good opportunity to think about prime numbers and to think about factorials.